So we promised to show you another way of doing this, and that other way is to force these bases to be equal. Okay, so first thing I'm going to do is I'm going to make them both 2's. So right now you got 4 to the x and 2 to the 4th, but keep in mind that 4, that's just 2 times 2, right, or 2 squared. So what I can do here is instead of putting 4 to the x, I can put 2 squared to the x equals 2 to the 4th. Now, that kind of seems silly to do, but what's sneaky about that is now I can use my power rule. Now, this is the power rule of exponents, but it is related to the power rule of logs that we used in the method that we're showing you on the other video. But that rule says that when you have an exponent to a power or a power to a power, we can multiply those together. So this is the same thing as 2 to the 2 times x, and that is equal to 2 to the 4th. And now my bases are the same, and so I can just say 2 to the x equals 4, because if the bases are the same, then the exponents have to be the same if the two things are equal. So solving this for x, I get that x equals 2, which works because 4 squared is 16, and 2 to the 4th power is also 16. Okay, now what's cool about this and why it's neat to watch this along with the other video is it doesn't matter what base I use. I could make them both 4's. So let's show you that. So here I already have a 4, so we'll keep it 4 to the x. And this one, keep in mind that this is 2 to the 2 times 2 power. So kind of use my power rule backwards. I can say that's the same thing as 2 squared squared. Okay, so usually we use the power rule to go this way and multiply these two exponents together, but I can certainly take it backwards and go the other way and turn it into this. So instead of 2 to the 4th or 2 to the 2 times 2, I'm going to do 2 to the 2nd squared. Okay, and now 2 to the 2nd is 4. So this is 4 squared on this side, and this is 4 to the x on this side. And again, using our equality property of exponents, if the bases are the same and the two things are equal, then their exponents have to be equal. So x equals 2. Now, you don't even have to do 4 or 2. Those are two bases that I already have here. I could do something completely unrelated, like let's do base 10. So I want to turn these both into base 10s. So first I got to figure out what power of 10 I need to make 4. So like 10 to what power equals 4, and I can get a good approximation for it. Actually, it makes sense to type in log base 10 of 4, because that's really how you find it, right? So log base 10 of 4 is 0.602. So what that means is 10 to the 0.602 approximately is the same thing as 4. So if I have 4 to the x, I can take this 4 and swap it out for 10 to the 0.602. So that'll give me 10 to the 0.602 to the x power. Okay, and then I got to do the same thing with 2. So how many times do you multiply 10 by to get 2? I multiply it 0.301, so that's telling me that 2 is equal to 10 to the 0.301 power. And so I can put here 10 to the 0.301 instead of that 2 that's there, and it's being raised to the 4th power. And so now using my power rules, I can multiply these together, and I get that this side is 10 to the 0.602 times x, and this is equal to 10 to the 0.301 times 4. It's kind of tricky how we write that. Make sure we remember that's a times sign and not a decimal. But yeah, so here we got the same base, and this tells me that 0.602x should be equal to 0.301 times 4, whatever that is. Okay, and if I divide both sides by 0.602, I will get my answer. Yeah, so this is kind of hard to tell what this equals, but it's going to equal 2. So it gave me the answer I got the other times, and I could do this with any base really. And what's kind of cool is this number here, we got that by typing in log base 10 of 2, and this number here we typed in by doing log base 10 of 4. And if you look at the video where we solve it by taking logs of both sides, this really does come up on those different ways. And when I do it the other way, using base 2 as my base, I basically get log base 2 of 2, which is 1 times 4, divided by log base 2 of 4, which is 2. And that's exactly what we did solving it the other way. And if I did it with base 4, I'd get the same thing I did. So it really goes to show that this world of exponents and the world of logs are really just the same world, just different ways of looking at it. So hopefully that was fun for you. Hopefully that helps some things make sense. And if not, it's just a fun little thing to see. So there you go.